So let's take a look at doing some examples of these quadratic models. For the first one, we want to find the location of the vertex, sketch a graph of the model, this XY axis down here. Let's go ahead and find the location of this vertex. And what we have with the location of a vertex is an X, Y coordinate. So we have an X value and we have a Y value. The X coordinate is found using that formula I went over in the previous video, the negative b over 2a. So what we're going to do, we are going to come up and take a look at our quadratic model to get our a, b, and c values for this equation. I included c. We don't need a c, but I think it might be easier to include it. C, B, and A. A, B, C. My C value is 4. My B value is -6. The understood lead coefficient of that x squared is a 1. So now I have my A, B, and my C values. I'm going to use my B and my A for my x coordinate. So I have the negative from the equation to find the x coordinate. So there's that minus sign, the -6. The a is 1, 2 times 1. So I have +6 over 2, which is 3. My x coordinate is 3. My y coordinate, remember from the first video, the way you find that is you take your model right up here, and wherever you have an x, you're going to plug in the x coordinate of 3. So I have 3 squared minus 6 times 3 plus 4. 3 squared is 9, 6 times 3 is 18, plus 4. I would have -9 plus 4, which is -5. I have the x and y coordinate of my vertex. I have the location of the vertex. Let's go ahead, so I've taken care of the vertex. Let's go ahead and sketch a graph of the way this parabola is going to look. The first point is my vertex at +3, -5. So there's my vertex. Is this parabola going to open up or down? That's the only thing I have left to decide. I come up here and I see my a value is a +1. That means my parabola is going to open up. So there is what I would have for the shape. That's not a very good parabola, but there's what I have for the shape of my parabola. Let's go through the exact same process with another one. We're going to find the vertex and the location of the vertex for this model, for this equation. Y is -4x plus x squared. So let's work with this one. I'm going to start out with the location of the vertex. Blank, comma, blank. Now, I am going to start with the x coordinate being -b over 2a. Now this one's a little bit trickier, and it starts up here with this model. The reason this one's a little bit trickier because this one's not written in standard form. My x squared is not my first term. So the way I can handle that is I can just switch those around, tack on a 0 for my c. X squared is now first, -4x is second, and c is 0. And the reason I had to do that is because I had to make sure I had that in standard form. So I could just read off my A, B, and C values. So my A value, my B value, my C value. C is 0, B is -4, my A value is +1. Again, and again, I had to switch that to get it in standard form. Now I'm ready to plug those values in to my x-coordinate equation. So my B value is -4. Can't forget the negative sign from the formula. My A value is +1. So I have +4 over +2. The x-coordinate is +2. Now, to find my y-coordinate, I'm going to use my model that I rewrote in standard form. That doesn't matter. I could use the original one. I could use this one that I created to put in standard form. And wherever I have an x, I'm going to plug in a 2. So I have y is equal to 4 minus 8. My y-coordinate is -4. So I've taken care of the location of the vertex. Let me come down here and sketch the graph. +2, -4. Whether this parabola opens up or down is all about the A value right there. So my A value is positive. My parabola is going to open up something like that. So there are some basic algebraic examples of this quadratic model and the way we solve for the vertex and sketch a graph. Let's take a look at solving a projectile motion problem. Here's what we have for the projectile motion problem. A projectile is anything that's hit or kicked or thrown into the air and has gravity act upon it. So we're talking about a football here, and what we want to do is sketch the flight of this football as it's kicked into the air. We want to find the maximum height this football flies through the air, the distance that it travels along the ground. So let's draw a sketch of what's going on with this football as it's being kicked, and you'll see the quadratic model in action. So there's the football, there's a kicker, comes along, kicks the football in the air, and gravity acts upon this football to make it go down after it goes up. This is a parabola that opens down, and the vertex location is right there. It's where the ball reaches the maximum height, and that's one thing we're trying to find. So we'll leave the football game and we'll take a look at going and doing the math to find the distance that this ball travels along the ground, as well as the maximum height this ball travels. So let's find the vertex location. Just like the other ones we did, this has an x-coordinate and a y-coordinate. My x-coordinate is -b over 2a, just like with the algebraic examples we did. My a and my b value are right here in the model. There's a and there's b. Let's take those values and plug those in to my x-coordinate formula. So I have minus -1.42, and I'm going to divide that by 2. Oh, that's positive 1.42, I'm sorry, 2 minus -0.03. So I have -1.42 over -0.06. Take out my calculator and get that value. I'm going to get 27.3. So still in math class, I'm going to put 27.3 there for my x-coordinate. My y-coordinate, I'm going to come up here and look at my model. Wherever I have an x, I'm going to plug in that 23.7. So my y coordinate is negative 0.03 times 23.7 squared plus 1.42 times 23.7. And from here, it's just a matter of doing some work in my calculator. I have to do the exponent first. 23.7 squared is 561.7. 1.42 times 23.7, 33.7. These two multiplied are going to give me negative 16.9. This is 33.7. My y coordinate is 16.8. Right, 16.8 there for my y coordinate. I'm done with math. Let me go back to the football game, put some units on these, and answer some questions. So, the football field is measured in yards. 23.7 yards is my x coordinate. 16.8 yards is my y coordinate. I've sketched a graph of this football. The maximum height that this football reaches would be the y coordinate of my vertex. My y-axis is located here. I wanted to see how high this ball flew through the air. My y coordinate, 16.8 yards. My x coordinate, 23.7, is we're going to use this to find the distance the ball travels along the ground. And it is 23.7 yards to the vertex location, but the ball has to fly another 23.7 yards to reach the ground. So I'm going to double that distance, and the distance that the ball goes along the ground is 47.4 yards. I add these two values together, get 47.4 yards, the total distance. So there's a projectile motion problem from start to finish, finding the maximum height and the distance along the ground.